faster, and so I won't have to keep you guys here the whole day, because it's a pretty nice Saturday outside. It's not been raining, and I don't want to keep you from your weekend activities because maybe you have more fun things to do than to come listen to me talk. But I hope to be able to do two things for you guys today. So if you don't know Python yet, I'm going to give you a nice introduction to it. If you do know some Python already and you want to learn a little bit more about the background, the philosophies, and maybe hopefully you'll get something that you haven't learned about Python yet. So unfortunately, if you are a Python expert, I'm sorry, you're in the wrong place. And then I'll do the same thing for App Engine. So how many people have heard of Google App Engine before? Okay, how many people have actually used it before? Ooh, a little less. Okay, now how many people have uploaded something that's running live on the internet now? Wow, okay, so it's gone down. All right, so I'll give you more information about that. So a little bit about my role. So you'll see that because this is a Python talk, this is like me. I'm representing Python. I'm representing Google, but when I talk about App Engine, then I'll become a company representative, get my shirt and stuff. Okay, so I lead two lives, one inside of work and one outside of work. So inside, I'm promoting Google technologies, and outside, I'm promoting Python. So I'm both a software engineer as well as an advocate. And part of my role at Google is actually talk to the outside, to interface to the global developer community. And so that's why you guys are here, and that's why I'm speaking to you today. All right, so yeah, so anyway, so if you have questions about something, feel free to just just raise your hand, and then I will answer your question when I have a moment when I finish talking about something, and then I'll ask you to tell your question, and then I'll repeat it for everybody to hear, and then I'll be able to answer your question that way. Okay, so Python is something that I've done for a long time, but before we get started, I want you to take a look at the three quotes up here. The reason why I ask you to look at these is because the interesting thing about it is that these quotes were made by very famous people who are an expert in a programming language that is not Python. Okay? Not Python. So for example, Larry Wall, he's the creator of Perl. Bruce Engel, he has written these very well-known C++ and Java books. And then Peter Norvig, who also works at Google, he's a very big Lisp celebrity. All right? But my point of these quotes is that even though these people specialize in a language that is not Python, they generally have pretty nice things to say about Python. All right? So the funny one is the one from Larry Wall, because somebody asked him over 13 years ago, why is Perl worse than Python? And he answered them this way, and I'm not sure exactly what it means, but Python people are very happy that he said that. So anyway, I think that the usage of Perl has gone down a little bit. Have you guys noticed that in the past 10 years? Perl usage has kind of gone down, and then I think I've seen like Ruby really kind of come up as well. So I think that's sort of a trend that's going on. But anyway, if you have any other questions that I can't answer for you today, feel free to drop me an email. And then if for some reason you work for a big company and you need to have the entire engineering team trained in Python, then feel free to go to my company website. You can see, either I offer both public classes in the San Francisco area, so if you come out to San Francisco, you take one of my classes, or I can fly to your company and help train your company internally. Okay. Okay. So first thing, if you don't know about Python, Python is very fun. I've used it at lots of different places. So the one that everybody knows, which Marcus mentioned in his introduction for me, is that we used it to build a web-based email system called Rocket Mail, which was the very second one to come out after Hotmail. And this was like in 1997, 1998. And Yahoo got interested in web-based email, so they acquired our company, and so we turned Rocket Mail into Rocket Mail. So that's sort of the history behind that. Yahoo Mail was built by like 6 or 7 engineers, and we did it using Python. 13 years ago when no one ever heard of Python before. We did the back-end data store that does all the email processing. That's done in C++, but all of the middleware and the front-end web interface, that was all done in Python. And a lot of people don't know that, so it's just very interesting how back then when no one heard of Python before, people were already using it. The interesting thing is wasn't allowed to tell people. So we were not allowed to tell people we use Python because it was so different. It helped people get their jobs done very quickly. You could prototype your code very fast, and it was so different that we didn't want the competition to know that we were using Python. So I was actually going to give a talk at a conference on how we use Python to build Yahoo Mail. And my boss and my managers, they said, no, you can't say anything. So it's one of those stories, right? And I ended up meeting Guido and Rosen, which I'll introduce you to. He's a creator of Python. And when I met him, I told him, oh yeah, we love using Python, but I'm sorry, we can't tell anybody we're using it. And he goes, you know what, that makes me mad. Everybody tells me the same thing. So it's a secret weapon, I think. So the fact that you guys are here now, it's really important, and the fact that we had the first Python conference here in the Asia Pacific region, I think that's really important because it shows that the interest in Python is growing very fast. The PyCon conferences in America have been, it's officially on year number 8 now, but there have been other Python conferences before that, so well into like 10, 12 years already. And there's also been one in Europe for a long time, but now that we have one in Asia, I think the rest of the world is starting to hear about it. So it's called Slow World Domination. Okay. So after Yahoo, I worked on my book, and so the very first edition of my book came out in 1999 or 2000. And then I changed jobs, and I went to use Python somewhere else. And I worked on these devices, these appliances made by a company called Ironport, which got bought by Cisco. And what those machines do is they run a very specific Linux or BSD kernel, and the whole purpose of the box is to filter email for spam and viruses. So that's what those boxes do. They can process hundreds of thousands of email messages every hour. And so at the core of it is a Unix-based kernel plus Python code. So it's a very special machine. So I've used Python for lots of different things. And so those are two things that I've used Python with. Another thing that I've done is this company called Nearby Now, which I worked at a few years ago. And what we did was local product search. So you're walking down North Bridge Road, and all of a sudden you have to go buy an iPod Shuffle or something somewhere. So the main idea is you should be able to take out your mobile phone and send a special code saying I'm looking for iPod Shuffle, and then my server will tell you where it is located around you. So that's only in America, but we had some problems because the economy got really bad in 2008, so all of the retail industry wasn't doing very well, so we could not continue that idea. But that's something else that I use Python for. And then at my last job, I worked at a company called Slide. So how many people are Facebook users here? Facebook? Yeah? And you guys do like poke your friends and maybe super poke your friends? Right? So super poke is done by our company, Slide. So most people know us by super poke, not by the name of the company. Okay? So it's just really sad. Right? How many people have heard of Slide before here, honestly? Oh, 2. Oh, okay, that's not bad. It's pretty good. And then the most interesting thing that I've used Python for is I've written software for doctors to help analyze patients that have a fracture of their spine. Okay, so that was using a UI. Doctors would just use a UI and mark the outline of the spine, and based on the measurements of this, doctors can quantitatively measure whether or not that person has a fracture or not in their spine. So I know a lot about osteoporosis and things like that. So that's probably the most different thing that I've worked on. My background is C, Unix, networking. That's where I came from when I got to Python. So I guess what I'm trying to tell you guys is that I've used Python for a variety of things. So it's not just only for web programming, or it's not just only for scripting. It can be used for lots of different things. All right. I'm excited. I'm here to talk to you more about Python. And as a software engineer, what is crazy enough to make somebody go and want to write a book? All right, writing an article or a paper is already hard, but it's got to be something very monumental to make me want to go and write a book on it, right? It had to really be a big difference, something I felt was very important. So I've written a lot of Python because I'm very excited about it, so that's why I'm here talking to you guys today. So this was the first edition of my book that came out back in 2000, and then second edition, which is the current taught it at both schools, at conferences, as well as at companies. So, so I actually do this a lot. Python is picking up, so there is a lot of training out there. Of course, until the economy went bad, and now the training budgets got killed. So that's why I'm working in a full-time job right now. All right, so of course this talk is not about me, it's about you guys, and who are you? You're probably some sort of hardware or software engineer, or you're a web developer, system administrator, you do QA, testing, automation, you're some kind of technology person, you know how to code in one other language, maybe one of these listed here. But you can't see this down here, it's a different color, completely different color than what I have. But these are just names of projects that actually lead people to Python. So they're discovering these technologies and then they find out that it's Python and they kind of really interested. So some of these are Django, TurboGears, Pylons, Zope, Plone, Trac, Mailman, and Google Image. So those are just some of the ways that people find Python. They may not hear about Python first, but then they get involved or they find out about another project which happens to be based on Python. So that's how they discover it. So why are you here? You were forced by your boss to come here to learn more about Python and App Engine, or you heard good word of mouth about Python, or you found out that very famous companies like Google and NASA, Disney, Sony, Ubuntu, they all use Python. Or like I said, you came from a different project. Oops, sorry. You came from a different project that was related to Python and you found it. Or you already know something, but you want to fill in some holes. Okay. So one thing is I was wondering, does anybody know what the O'Reilly Safari service is? That's where you can subscribe, get PDF access to books and stuff. So last year I gave a webinar, and I was asking the staff there, so when people are searching for new books to download into their Safari library, what are the most popular things that people are looking for? What are your top 5 searches that people do when they're looking for another book to read? And so here's the list at that time, in April of last year, what people were searching for. It's very interesting, this list, right? Probably not a total surprise to you as far as the names that are on the list, but it's just interesting to see what it is. And I guess now, if we were to look at today, maybe Android would be over here in the top 5 or something. But I don't know, it's just interesting to look at. Another thing that I find interesting is this TOB index, which you can find at, can't see it, but I have another link later on that's a bit bigger. But TIOBE.com. It's just a website that through various means, I'm not sure exactly what their algorithm is, but what they do is they look at trends in programming languages. They find out like what companies are using a language, how many downloads are they getting, how many books are being written, how much chatter is there going on in forums and Stack Overflow and magazines and newspaper. And so they kind of give a really rough estimate or ranking as far as like what are the most popular programming languages out there today. And this particular chart shows you like over 5 years what has happened. What was in these positions recently as well as 5 years ago, and certain numbers are involved in the changes between 5 years and what's happened. So it's very interesting to see that, for the most part, Java, C, and C++, and PHP, and VB are pretty stable in the top 5. But it's very interesting that Python is, well, I guess it's interesting but not surprising that it's made a pretty strong impact. It's moved up several places. And of course, Perl has gone down several spots, and then Ruby has just all of a sudden broken into the top 10. So it's just an interesting thing to look at. I can't, you don't want to really take this as a hardcore evidence because, like I said, they're not publishing what their algorithm is. So, not really sure what they, how they arrive at these numbers, but it is interesting to look at. Okay, so Python is very good for new programmers, people who have never programmed before. The creator of Python feels that programming is a basic skill that should be taught to children, just like reading and writing. Okay, so that's his philosophy. Not that everybody's going to become a programmer, but in your life, everyday life, no matter what your career is, you have to do some kind of programming anyway. Using your mobile phone, telling the microwave oven how long to cook your food, controlling your DVR and what kind of shows you should be recording for you so you can watch later, right? That's really programming. It's not using computer code, but it is programming of sorts. So that's his main philosophy. And so for people who have never programmed before, and if they decide they want to try it, they should have, they should have some mathematical background. Maybe it's great that they have someone else that they know who's already a developer, but they really should be curious and willing to just kind of figure things out. How can I make something do what I want it to do? So Python is a very good language for that purpose. So in this hour that I'm going to speak to you, I'm going to try and introduce as much Python as possible, but I'm also going to give you like a lot of background about me, background about the language and its philosophy and things like that, so you can have a better idea as to where it's coming from and where it's going and why it is the way it is. And then technically, these are some of the topics that I'll cover today. Okay, very, very short, but just enough information so that you know something about it, so that when you go back and read or you want to try it out, then you'll have a better idea as to what's going on. Okay, so when was it created? Believe it or not, Python is almost 20 years old. It's not exactly a new language. And some people are very surprised to find out that it's been around for so long. But hey, I told you the main reason is nobody's saying they're using it. So no one's ever heard of it before. So that's why that's why it's been around for so long and nobody knew that. But anyway, so Guido van Rossum, unless you're Dutch, if you're Dutch you pronounce his name correctly. But if you're not Dutch, then you just call him Guido. He started working on it around the holidays in 1989, and he worked on it because when he was at the Dutch research lab that he was working in, he had to do some system administration tasks. And on these systems that he had at the office, the only tools he had to do were just, he had to write system administration tools, but he only had two options. Either you write it in C, again, you're actually writing something that moves files in C. Okay, it's not really that fun. All right, so doing it in C or doing it in ABC, which is an experimental new language to teach kids how to program. All right, if you're trying to teach children how to program, the language is not going to be exactly have a lot of system call capabilities. Okay, so he only had those two options, and neither of them were good choices. So he created Python to be a combination of those two. A language that is as powerful as C, C++, and Java, that also has a syntax easy enough to teach children how to program. So that's where it came from. And instead of creating yet another language from scratch, he had already studied a lot of programming languages in his career. And so what he did was he picked his favorite features from these programming languages, a variety of programming languages. So you can think of Python as a greatest hits of all the programming languages that he's experimented with. Okay, so it inherits from all these languages that you see over there, and then even more that I didn't have any room to fit. And it's named after the British comedy troupe, not the snake, even though snakes appear on most Python books. Okay, that's just the way it is, right? Can't control that. It's available on pretty much every platform you can think of. All you need is a C compiler, and then you can have it run. Very interestingly, you can get Python on mobile phones. You can get it on, Nintendo GameCube, Sony PlayStation. Traditionally things that don't have that programming involved with them. So anywhere there's a C compiler, you have access to Python. And there's also alternative implementations of Python. So you can get a Java version of Python, and that's called Jython. So it's Python code that runs on top of the JVM. And then there's also a version of Python called IronPython, which runs on top of .NET. So it's a .NET language that's written in C#. So you have more than one option. There's actually more than just these two. It's just that the other ones would be of less interest to you. So what are some of the philosophies of the language? It has to be robust. What does that mean? That means that when you download Python on your system, you should have enough tools to help you get a basic application done. All right, they call it batteries included. All right, you don't have to go and buy it separately. Okay, so and it should be simple. Syntax should be clean, easy to read, and a lot of people say it's even easier than VB. It's modular, which means it's very plug and play. You only grab things that you need. Okay, so if you need to do database access, you import the database module. You need to do network programming, you import the socket module. But if you don't need those things, you don't import those at all, so it keeps your code nice and segmented, so it's divided up very logically. Okay? If for some reason Python doesn't do what you want, you can extend it. That means you can change the way it works in general, it should be enough to help you get your job done, but if for some reason it doesn't, then you can extend it. It's very intuitive. So another quote that came from Bruce Eckel, the guy who wrote the C++ and Java code, he said, Python fits your brain. What does that mean? That means that if you're sitting at your computer and you're ready to code a solution, you should be able to think about what the algorithm is that you're trying to do it, and you should just be able to type out some pseudocode, and that should be very close to working Python code, if not already working. All right. So as soon as you can think of the solution, you can code it right away. So you can code as fast as you think. That's what people say. It's object-oriented when you need it. Okay, so what do I mean by this? So for example, if you guys know Java, you know that everything has to be a class. And you have to do everything in an object-oriented way. But Python, even though it's an object-oriented language, it doesn't force you to do object-oriented programming. You can just do regular structured programming. You know, if you just want to write a script file to do something and do a couple of things, you can do that. But if you want to write a large application and have as many classes as you want, that's perfectly fine too. All right? It's just Guido wants to be able to pick the right tool for the job, and doing hello world using a class is probably not the right thing to do. Okay? It's just extra code that you don't really need. You should just be able to do hello world, and that should be it. Okay? So that's some of the philosophy that Guido had when he designed Python. All right, so some of the advantages, I already talked about the syntax, coding very quickly. It gives you a lot of high-level data structure so that you don't have to go and do it yourself. It's object-oriented. It has exception handling, which means it's able to detect runtime errors and gives you, the programmer, the ability to monitor for those errors and take specific actions if those errors were ever encountered in your code. You know, that's certainly a lot better than having your program crash and having it quit, right? That might upset some of your users. So exception handling is a very nice feature. Python is not a functional programming language, but there are features from well-known functional programming languages that Guido has brought in, you know, from Lisp, Scheme, and Haskell. So some of those features are actually found in Python. Like I said earlier, you can also extend it. So the regular version of Python called CPython, you can extend it in C or C++. You can extend the Jython in Java, and then you can also extend IronPython in C#, or if you're crazy enough, you can extend IronPython using VB.net. Okay, kind of scary. Like I said, batteries included, so there's many libraries to help you get your job done. Networking library, databases, GUI programming, multi-threaded, XML, regular expressions, operating systems, file system, math, web, plus a lot of third parties. Okay, so there's a lot of tools to help you get your job done just when you download it. Okay, so it's a great tool to get something done. Right, you don't have to spend a lot of time with configuration, with worrying about memory management, with all these additional details that are in the way of you solving the problem that you need to solve. But the best thing I have to say about Python is the community. All right, people that are in the Python community are very welcome, they're very open, they're very friendly. There's not a lot of fighting. I mean, there's a lot of strong disagreements, but not a lot of violence and things like that. So if you ever go to a Python conference, you will find that it's very addictive. You want to go back to every single one that you can go in the future. So you just have to be careful. If you make a commitment to go to one, you're going to have to commit to going to like another 200, or as long as you can. But it's a great atmosphere, and it's a great community. What are some of the disadvantages of using Python? Well, obviously it's not going to, your code is not going to run as fast as a compiled language like C or C++. Some people think that the idioms are really strange, like you have to code Python in a very particular way to get it to do something that you consider normal. Okay. Some people think the syntax is really strange. Those of us who are coming from C, C++, Java, PHP, we're used to having curly braces to indent blocks of code with, right? To have a sub-block of code. But in Python, it's just pure white space indentation. There is no braces. So a lot of times people are like, oh, it's shocking, and it makes you really mad, and your face gets red and everything. But it's okay. After a few months, you'll calm down. It's like taking yoga. You'll be at peace. Okay? You'll discover that it's impossible to have a dangling else problem. You guys know what dangling else is? Right? You have if, and then else. Which if does this else belong to? all right, you can make a really bad mistake if you're doing it in C, C++, or Java, because even though it's spatially indented, it may not actually be part of that if that you think it's part of, all right? But in Python, it's impossible, because if you have two ifs, they're indented at different levels, and whatever level your else is indented at, that's going to be the matching if. So you'll never have this issue where visually it looks right, and it doesn't behave that way, so you're never going to have that, all right? So that's one thing that people have to get used to, is the white space indentation to deliver the block of code with. There's no real large marketing force, like Java has a big company behind it, Sun, Oracle now, I guess. It's just, like I said, we're not even allowed to talk about talking to people and let them know we're using Python, so it's a very quiet world domination environment. Okay? And that's why you guys are here, you're part of that plan. And then here is a full link to that language history chart, popularity of programming languages. I know it's impossible to remember, but I'll give the GTUG people the PDF so you guys can go download it, so you don't have to go do this. But you can just go to tob.com and chase links down and be able to find the right thing. All right, so so I'm not talking to you guys. It's built for non-programmers. It's educational language syntax. It works great for kids. In America, there is this thing called the Advanced Placement Exam. So when you're doing secondary school before you go to university level, you could actually take enough computer science in secondary school to bypass. If you take this exam, you can bypass the first year of your undergraduate computer science program. And so in high school, as it's called in America, it used to be done in C++. So can you imagine when you were back in secondary school and you had to learn C++? That would be really fun, right? You would not be interested in technology anymore. Okay, so the test actually has changed to Java, but it still doesn't change the fact that it's not really fun for kids. Okay, so one teacher in the Washington D.C. area, it took him 2 years of teaching C++ to prepare a student to take this exam, and he discovered that the children were losing interest, all the girls were leaving. It was bad. Okay, so what he did was replace the first year with 1 year of Python, and then he did the second year with C++ as he did before, and he discovered that he had many more students who were interested in the class. It didn't take them as much time to learn C++, and he generally had a much more favorable response from the students. So, this really goes to show you the power that Python had, and that is that instead of letting a lot of these syntax issues get in the way of just learning computing concepts, that Python was able to help with retention of students, to make them feel better about programming in technology as a career, and to have better understanding as far as computing goes. So I think it's one of the best first languages for children. I can't say it's the best, that's why it's in quotation marks there. I think there's other languages that are a little bit better as a first language. I don't know if you guys have heard of Scratch or Alice. Okay, yeah, okay, see, Alice people over here, all right. Scratch is good too. It's just competition between MIT and Carnegie Mellon. That's really what it is. Okay. But I think those two are really good languages because they're more visual. And then, if children want to do Python as their second language, I think that's the best thing. But if you're already like in high school, or if you're already in university, you can just start with Python right away. Okay. So with that said, if it was written with children in mind, what happens for all of you who already know how to program, right? Should be really easy. Okay. All right. So there's a lot of books now that are meant for people who are absolutely new to programming, and some of them written with children in mind, like this one, Computer Programming for Kids and Other Beginners. This is a very interesting book. It actually gets really good reviews. And it was written by a father who's an engineer and his 8-year-old son, okay, to give the child's perspective. So it's a really interesting book. And if you want to teach your kids how to program, then take a look at that. But there's other ones that are written for beginners as well. And then there's a couple of university textbooks over here. My book is also used at some universities, but it's not a computer science book. It's mostly teaching you about Python and teaching it in depth and comprehensively. That's really what my book is about. But I have a lot of exercises at the end of every chapter, so you can actually test the knowledge that you gain. And so I think that's some of the reasons why some professors decide to use my book in their classes. But I don't have any control over that. But very interesting to see. But then there's, of course, a lot of online books and tutorials as well. So now we're going to start looking at real Python stuff. Well, one of the tools that you'll be using throughout your entire careers if you start doing Python is this thing called interactive interpreter. And what this is a shell, a command shell that lets you type in Python commands to test out to see how they work, to debug things, to try new things. So it's a really useful tool. And I've been doing Python for like 14 years in a row, and I still use this thing. All right, it's very, very, very useful for you. Okay, you can either do it using the IDE that comes with Python, which is called idle, or you can do it from the command line. You can do it, from a Mac or a Linux machine, or you can also do it from a DOS command window. It doesn't really matter. So you just pick whichever one you like. You want the GUI style, or you want the command line style. They're both exactly the same. And so what you'll see is this greater, and what that is the Python prompt, and then you can type in any Python command, and then just hit return, and it'll execute it for you. All right. So it's a pretty useful tool. And so this describes what you saw on the previous slide, except for things that you can't read, which is again a completely different color here. So greater is the Python prompt. That means if you're ready to enter any Python command after that, and you saw the print statement, so you can use print to display output to the users. The next generation of the language is called Python 3, and print is changing to a function, so you actually have to do print with parentheses and whatever you want to print inside the parentheses, right? So this is a minor difference. And then to quit, you just either type Control-V or Control-Z, depending on what you're using. If you do like to use an IDE or integrated development environment, it gives you lots of other developer tools, like it lets you, do a stop and step execution, it lets you set a breakpoint, lets you do all kinds of extra things that you can't get on command line. And like I said, the interactive interpreter is very useful for testing, debugging, hacking, experimenting. So one of the things that I like to do with the interactive interpreter is I hack around with code. Once I get it working, I just cut and paste it into my .py file, and everything is working the first time. So I can write bug-free code. And so can you. Okay. All right, so how do you get Python on your computer? If you have an Apple, a Mac, or any kind of Unix machine like Linux or BSD or Solaris, Python should already be on that system. The only people that need to really download it are people with PCs. Okay, so you can just go to Python. Go to python.org to download it, or you can actually go to my books website for Python. The reason why I have that there is because I have to have multiple versions of Python on my computers, and because of that, if I go to the main download page for python.org, I have to click various links to get different versions for different computers. So what I did for my books website is I put it all into a big table. So Python, 1516202324252627, and then Mac, Windows, Linux. So I put that all in one page. So you don't have to go and hunt them down. So either place you go down or and the IDE that I showed you on the previous page, this one, it comes free with Python when you download it, but it doesn't have a lot of features. So this is another one. It's called SPE, or Stanny's Python editor. And so that one is, it's more realistic. It's got a Python shell down here. It's got a list of your classes and your modules over here. It's got your code over here. So it's a little bit more of a real IDE than the one that comes with Python. So you just kind of keep an eye on those. There's other ones like Python Win, Eclipse, Hyperstate, WinWare. Those are other well-known IDEs. So it depends on what kind of person you are. If you're a command line person like me, you don't really need to worry about an IDE. Okay. So that's that. Some things that beginners get caught up with. There's a lot, besides not having braces for indentation, there's just not a lot of symbols. Guido is like no symbols. It gets in the way of you seeing the solution you're trying to build. No parentheses around your given condition. No semicolons at the end, no dollar signs, no nothing. It's just very basic. Only looking at code, not looking at extra decorative stuff that gets in the way and makes it messy. All right? There's no switched case statement, no private class members, no plus, minus, minus, no static pipe checking, no anonymous blocks. All right? Not really necessary. None of those things are really necessary. Some people will argue that having private is good, but Python gives you something better than that. Right? So if you guys are familiar with C++ and Java, you're familiar with like public, private, protected, friend, all those things, right? Everybody knows that, right? Python, it has none of those things. Everything is public. But for those of you who come from C++ and Java, it's like, oh no, how can that be? That's terrible. There's no security, right? It's even better than just those 4. You're given, it's a limited selection. All right, with Python, you can program these things called descriptors and properties. You can have full control over your classes and how they get used. All right, so instead of giving you 4 things to choose from, Python gives you a tool so that you can build your own security policy however it is you want to have it done. So it's better than limited choices that you have. This is one thing that will confuse people when we move to the next generation of Python. 1 divided by 2 is not 0, okay? So throughout most languages, 1 divided by 2 is 0. But remember, Python is used to teach children how to program, and you try to convince a 9-year-old student that 1 divided by 2 is 0, it's not going to work. Okay? Right? You're going to have a long battle with the child. Okay? So starting in Python 3, 1 divided by 2 is a half. If you want 0, if you really want 0, because you're a hardcore hacker, you can do 1///2. So that is the new floor division operator. Okay? I have another slide on that. Floating point numbers, I have a long history. Okay, so if you type 1.1 in the Python interpreter, you actually see 1.100001, and you think, oh my gosh, is this a Pentium floating point bug again? Okay, no, it's not true. It's the fact that it's very hard to represent a repeating fraction using bits. Okay, and so there's a whole web page on this, but you know, the math generally works out fine. If this really you don't like this look, then Python has another type called decimal, which will be, you know, which make all the financial software people happier because they get nervous about this kind of stuff. You know how you can slowly take one small fraction of money and just move it to the side somewhere. You guys know. And then there's a grouping. Python has a grouping called a tuple or a tuple, depending on how you want to kind of pronounce that word. The one tricky thing is if you have only a 1 element in your tuple, you have to have a comma. Because otherwise, if you just have it closing parentheses by itself, it's going to be like parenthetical grouping, and you're going to lose that. It's not a tuple anymore. It's whatever the object is. So that's another thing that beginners get caught up with, especially Django programmers. Okay, so a little bit about objects in Python. They're allocated on assignment. It's not like in Java or C, C++ where you have to pre-declare variables. You just start using them. If you have x equals 1, Python is going to look, hey, what do I have on the right-hand side of the equals sign? 1, that's an integer. Therefore, x should be an integer. Okay, so it figures out what type it is based on what you have on the right-hand side of the equals. So that's why you don't have to pre-declare. Okay. You can also create additional references or alias. They're kind of like pointers. All right. So if I did x equals 1 and then y equals x, they're both looking at the same object instead of having 2 copies of the same thing. Okay. And then as far as memory management goes, Python does it by reference counting. So if you do have x equals 1 in your code, and later on x goes away, and there's no other variable looking at the 1 object, that gets garbage collected. Okay, so that's how it does it. It figures out how many people are interested in this object, and if nobody's interested anymore, then the memory is free. Okay, so it happens automatically. Now, what are Python's standard types? Depending on who you talk to, there are between 3 and 8 numeric types in Python. Okay, there's 3 core types, but then you start going, oh, well, that's kind of a number, and that was a number, and that was a number. So there's really up to 8. All right, so I'll show you what all those are. There's 2 to 3 string types. There's the list, which is like an array, but it's heterogeneous. There's tuples, which are like lists, except that they're read-only. Dictionaries are hashes, hash map, hash array, associative array. And there's 2 types of sets. So those are the standard types. And then there's some other types. Python's null object is called none, and it's spelled with a capital N. Files are objects, functions, methods. Of course, Python's object-oriented, so everything is really an object. Okay, so some of these, they're just some of these other ones. Okay, but they're not really data types. They're just types. Okay. All right, so one of the best things that you can do when you start Python is just bring up the interactive interpreter and just play with it like a computer. It's a very expensive calculator. All right, so you can just start typing commands. Like you can confirm that the math operator hierarchy is the same as before. So that's like 4 plus 6 times 5 is 34 and not 50. And similarly, 4 plus 6 to the power of 2 is 40, not 100. Okay. So in this first case, you can just see that Python dumped out the contents of the the results. And in this case, I actually assigned it to a variable a, so I did have no output. If I wanted to dump out the contents of what's in that variable, then I just type in the name of the variable and I hit return. Like I said, Python does auto garbage collection. So if I assign a to a string now, then Python automatically garbage collects the 40 because nobody else cares about the 40 now. Here, B is another string, and then I can show you that operators can be overloaded. So for numbers, plus means addition, but for strings, plus concatenation. Okay, so I can do this. Of course, you can see that Python does not automatically add space for you. So if you really want a space, you have to add it yourself. And then here, in this example, I'm reassigning it back to A. And when I dump on A again, I can see that it added my space. Okay, so just very basic things that you guys can do today. All right, so again, I apologize for the colors. Maybe let's move on down here. Integers. Okay, so these are the three numeric types. Integers. There's no size limitation except for how much virtual memory you have. All right, so they're unsized. You can make them as big as you want. Very useful for scientific programmers who want to use large prime numbers. Floating point numbers are the same thing as a double in C, so it's a double precision floating point number. Python also supports complex numbers because it's used a lot in engineering and scientific calculations. So those are the three main numeric types. Now the other type, the other five, between 3 and 8, there used to be an old integer type called long because int used to be sized, so it used to be like 32-bit. But then those two merged together, so now it's really one single unsized integer type. So the longs will go away. They're still around in Python 2, but in Python 3, they're no longer there. Python has the Boolean type. The values are false and true, but if you use them in a numerical context, like I want to add something to it, then they take on the values of 0 and 1. So they're also numeric in that way. The decimal type I mentioned, if you want something a little bit more accurate than floating point numbers, you can use that. There's also a fraction type and a rational type. So really those are the 8. Okay? And then there's some math, some numeric related modules like math, CMath, random and operator that you can read about. Okay, so those are Python numeric types. Standard operators, there's the usual plus and minus, times. I already told you about the two division operators, modulus, exponentiation. And then in the second row, we have the bitwise operators. So you can do left shift, right shift, and, or, exclusive or, and complement. And then the comparison operators, I can have equal to, not equal to, less than, greater than, equal to, less than, equal to. And then we also have is, not, and, or, and not. So instead of having like amper for and, or pipe for or, it's actually the actual word A and B and then or. Okay. You can have grouping, like I said, with parentheses. As I mentioned, the slash means true division in Python 3 and classic division in Python 2. So in Python 2, 1 divided by 2 is still 0. And of course, you use double slash, like I said, for floor division. And you can also do augmented assignment. So like x equals x plus 1 can be written as x plus equals 1. Same goes for minus equals, times equals, etc. You just don't have plus plus and minus minus. So those are the two things that you don't get. All right, strings. So Python does not have a character type. All right, and because of that, it doesn't matter if you use single quotes or double quotes. They do exactly the same thing. Okay, but I'm lazy. I want to press the shift key, so I just use single quotes. Okay. There's also the string format operator, the percent sign, which lets you do printf-like functionality. So I'll show you that. And then also Python has another concept which I have not found in any other programming language, and that's called triple quotes, where you have 3 singles or 3 doubles. So I'll show you that as well. So we'll take a look at these examples here. So here I have a string called Python. I assign it to S. I'm an example of overloading of the asterisk so that you know how the plus is concatenation, but the star is repetition, so I can make multiple copies of the same thing. And of course, it's not really useful in practice. The one thing that you would do is something like dash times 80 to get a horizontal line or something. That's like the big thing that people do. So anyway, so that's times 2. I'm going to reassign it back to S. So this is, of course, the same as X. S times equals 2. And now I have Python as my string. I can take a subset of my string with indices by using square bracket notation and a colon. And so what these numbers mean here is I'm going to start at this index, okay, 4, and I'm going to go up to but not including 6. Okay? So like other languages, Python starts counting in 0. So this P is at 0. 1, 2, 3, 4, 5, but not including 6. So I'm going to take this O to N here, so that's why that's the output here. You can get to the last character of your string by doing -1, so you can index backwards. Okay, and then you can also do negative indices with a full subset, like -4 all the way up to, but not including -1. So -4, -3, and -2. T, H, and O. So that's why that's the output here. And if you leave off the index at the beginning, it'll just assume you want it from the beginning, or if you leave off the other one, it goes all the way to the end. So in this particular case, I'm going from 0 up to, but not including 6. So 0, 1, 2, 3, 4, 5. I'm taking the first half of this string. Okay? And so in the next example here, I'm showing you an example of a format operator. So %s means I'm going to substitute in a string here. %e means I'm going to substitute an integer here. Okay, so this comes straight from like C and C++, if you know those. And then I'm going to have a string format operator here, and then I'm going to have a tuple where they have to be presented in the same order. I have to pass an object for a string, so I'm going to take this string again, half of the Python string, and then for the number I'm going to pass it 1. So this gets dropped into here, this gets dropped into here, and so now I have my new string with everything formatted. Okay. Here's another example of string concatenation. I'm going to take Python, the half of Python, and then add this is pull up represent 4. And then the last demonstration is the triple quotes. So I could say my variable hi equals, and I could do 3 quotes, type hi, and then hit return, and then type the rest of my string, and then close the quote. And now if I dump off the contents of this variable to my screen, I can see that it's automatically embedded the new line in my string for me. And then when I print it, it renders that character. You guys see that? Okay, pretty useful, right? So in practice, where this comes in real life is, your marketing person gives you a whole chunk of HTML. You don't want to like format that, make your code wrap around, make it really ugly, right? You just take that HTML, drop it into your code, 3 quotes at the top, 3 quotes at the bottom, assign it to a variable, then you're done. Okay, very useful. So you can actually take it verbatim. So it's a nice tool. All right. Does everybody understand that? Any questions on strings? Okay. How are you doing, guys? Asleep yet? Okay. Yeah, I'm trying my best. Okay. All right. Lists and tuples. So they're ordered sequences of heterogeneous objects. So they're just think of them as an array, except that when you think of an array, it's like, oh, I have an array of integers, I have an array of characters, an array of something. But in Python, they could be anything. I could have numbers and strings that all be mixed together. So that's why the word heterogeneous is there. Heterogeneous means they can be mixed types. All right. Mutable means their values can be updated. That means I can change it. Once I create this object, I can change it. Believe it or not, most Python objects don't allow you to do that. Once you make objects, they usually don't allow you to change them. But lists are one of the few data types that do allow you to modify them. And like I said, tuples are very similar, except they're not mutable. And they don't allow updates. And then there's another construct called list comprehension, which I will talk about on the next slide, that allows you to build the contents of a list using some logic. Okay, so it's a very useful tool. Some of the things that you can do with a list is, now that you have a list of something, you can sort it. All right, of course, that only makes sense if they're all the same type. If you have a list of numbers, you call sort on it, it'll do what you expect. Same goes for strings. If you actually have mixed types in there, that's a little bit tricky because there's no definition for that. What does it mean to sort list, to sort a list of numbers and strings? It doesn't make any sense. So that is sort of an undefined type of operation. And in Python 2, Python actually guesses as to what you want. So what it'll do is it'll sort all the numbers first, then it'll sort all the strings and give it to you. But in Python 3, that's not allowed. So you just get an error saying, I'm sorry, I can't sort this because you have numbers and strings in here, and they don't compare. All right. You can add things to the end of the list using a pen. You can take things out using pop and remove. You can find out, do I have an object in my list, and if so, where is it? That's what index does. And then insert allows you to add things arbitrarily in different places. So a pen only adds at the end. Insert will let you add anywhere. Okay. All right, so here's an example of how to use a list. So I have a list here that has 4 items in it, 2 strings followed by 2 integers. I'm going to add another string to the end, right after the integer. Then I'm going to insert insert another string in the middle in position 1, so 0, 1 right here. So now when I dump out the contents of my list, I can see that yes, I did add the one to the end here, and yes, I did insert this one in the middle here. And then because the list is a mutable object, I can change it. So notice that I made a typo, I made a mistake, so I can kind of correct it. So I can do m bracket 1 is this string, so I can actually fix my spelling mistake. I can remove the item at index 3, which is the 4th one, so 0, 1, 2, 3, I can take out the 9 and get it returned to me. And now when I dump out the contents of my list again, I can see that my spelling correction in the index 1 is correct, and then also my previous 9 that was in there has been removed. Okay? And then, like I said, in Python 2, you can call sort on it, so it'll sort all the numbers first and then all the strings afterwards. But this won't be allowed in Python 3 anymore, so just keep that in mind. And then down at the bottom are examples of what is called a list comprehension. And what that is, it's a little bit of logic to help you build the contents of the list. Okay, so we haven't covered the for loop yet or if statement, but let's try and read this. Okay, so the way you do a list comprehension is you start out with the for loop first. So you do for I in range of 20. What is range of 20? Range of 20 is just the same thing as counting from 0 up to, but not including 20. So that's really 0 up to 19, right? And what it'll do is it'll check for every number from 0 to 19 if that number, when divided by 2, gives you a remainder of 0. In other words, there's no remainder if you divide by 2. So what kind of numbers are those? Even numbers. Okay? So even numbers between 0 and 19. So that's 0, 2, 4, 6, right? So now that we have that, what do we want to do with every single one of those numbers? We want to multiply them by 3. Okay? And then the whole thing will be the resulting list of numbers that I want to have. So 0 times 3, 2 times 3, 4 times 3, 6 times 3, etc. up to 18 times 3. Okay? Otherwise, if you were to build this manually, it would require more lines of code. So this is a very fast way to build a list, and now I could have assigned this to a variable if I wanted to save it. I did it in this example here, but I could have, and then I could use that for processing later. All right. The old way of doing it is you create a blank list, you do a for loop, and then you just do .append, 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 .append. Okay, that's not that great for performance. It's a lot faster to create your entire list at one time instead of creating an empty one and then making it bigger, making it bigger, making it bigger, making it bigger, because you have to continually add more memory to it. Okay, so that's why list comprehension is kind of useful. Some people think that you can only use mathematical operations with the list comprehension, okay, like we just did, but that's not true. Here's an example of something that doesn't involve any math. So I'm going to open a file. I'm going to read into the file. For every line in my file, I'm going to strip off the leading and trailing white space. And then data is going to be a list of strings that are in my text file, only it doesn't have all the trailing white space and leading white space characters. Then I close the file. Okay, so that's an example of using list comprehension that has nothing to do with math. All right, everybody okay with lists? Pretty basic, easy to understand. Can you customize the sorting? Yes. Okay, so the question is, can I customize the sorting? And the answer is yes. And the way to do that is, in sort, you can actually pass in an algorithm for what you want. Like, what is the sort key? Or if you want, you can pass in a compare function, but that does not work as fast as passing the sort key. So you can say for an array of 2 tuples, I only want to sort by the second element, or something like that. So the answer is yes. You can customize your sorting. You can also sort in reverse. There's a flag that says reverse equals true, and then that'll do it backwards. All right, let's talk about hashes. So Python dictionaries are Python's only mapping type. They are also mutable. So they're, again, one of the few types that allow you to change the contents. Now you can disagree with me, like, after my talk is over, you're going, wait a minute, if I do x equals 1 and then I do x equals x plus 1, didn't I just modify a number? It's not true what he said, that numbers are not mutable. Okay, so you might disagree with me, but just trust me. Okay, numbers and strings and anything that's not a list or a dictionary is not mutable. There are very few mutable Python types. So it's just key value pairs. So that's how you think of these things, key value pairs. All right. Keys have to be scalar. In other words, they're usually strings or numbers, but values can be any arbitrary Python object. You cannot have key collisions. So if you assign something with a certain key, and then later on you assign something else with the same key, that first one gets replaced. So if you've done Java or Perl, it's the same, very similar to a Java hash map or a Perl hash or associative array. Here are some very common methods that you'll use. D.keys will give you all the keys of a dictionary. .values will give you all the values. And then .items is a combination where it gives you key value pairs. .get will pull out an item from a dictionary. And then .pop will remove it. Okay, so get just gets you the value, but it leaves it in the dictionary. Pop will get you the value and take it out of the dictionary. And then update is where if you want to merge the contents of two dictionaries together, you can do that. So let's look at a demonstration here. All right, so this dictionary I have two elements. I have a string and an integer, and both of the keys happen to be strings. Okay, so I have two key value pairs in my dictionary. Because it is a hash table, if you guys know what a hash is, you know that the lookup is not sequential like an index, like with the list and the string. Okay, so you don't use an index. It's done by hashing of the key. So that because of that, the ordering is arbitrary because it's based on the hash function. So even though I typed it in this order, notice that when I tell Python to dump out the contents of this dictionary, it shows up in a different order than when I typed it in. All right. So they're just unordered. All right. You just have to live with that. All right. I can check whether or not I have this key that's in my dictionary. Is it in my dictionary? Yes. And is this key in my dictionary? No. I can try and get on this non-existent key. All right, so there's two ways of actually getting the value out. You can do it this way, or you can do it key bracket pub. The problem is because this key is not in the dictionary, if I did it this way, I'm actually going to get an error. It's going to say key error because this key doesn't exist. With a get, you have the ability to pass in a default just in case it's not there, so your program will crash. All right, so in this case, of course, this key does not exist. Okay, therefore I get the default value. I can add something to my dictionary by just assigning it to this, so d bracket pub equals the string. Now when I make the exact same get call, instead of getting the default, I actually get the real value because it's now in there. All right, and again, I won't get a key error now if I do it this way. But the thing is, you never really know unless you do a check. If you do a check, that's fine, like this. But if you don't do a check and you don't want to have your program crash, then using get is very useful. Okay. Question? Python take care of multi what? Oh, multi-threading? Python is not multi-threaded, so there's no issue. It's a single-threaded server, single-threaded virtual machine, which has another, that's another talk for another time. There's a lot of talks online already about that. It's a sort of bitter thing. But anyway, yeah, there's no need for worrying about it. Python does support a concept of multi-threading, and they do have thread-safe data structures available for you. But in this particular case, not with the standard type. You can subclass this type and make it thread-safe if you want, though. Then the last example is how do people typically iterate through a dictionary, iterate through the key value pairs? They'll just do for every key in my dictionary, print each key, followed by a colon, followed by the value, which is the bracket of those keys. I know I'm not going to get an error like this because I am going to ask Python to give me all the keys that are in the dictionary, so I'm not going to ask for one that's not in the dictionary. So I guess that could lead to your threading question. What if I have another thread that actually took out a key and I'm iterating through it, will I be in trouble? So yeah, that could be problematic. I don't think it's thread safe. But anyway, like I said, that's another topic. And here you go. All right. Any questions on dictionaries? Okay. All right, so if statements, should be pretty familiar with them already from another language that you already know. So here's an example of, I'm going to ask the user to type in yes or no. What you can't see really well here is there's a RAW with an underscore. So in Python 2, the name of the function to get user input is called raw underscore input, but it's going to be renamed to just input in Python 3, or it is renamed to input in Python 3, so that's why I have it colored out. do is if for some reason you want to make your code case sensitive, so if the user has their caps lock key on, if they type in capital Y or N, it'll still work. So this is only if you want that particular situation. It's not required. There's also other ways of doing it. One thing that's bad about doing it here is that, you know, as soon as the user types it in, you're actually modifying that string. So, and before you're saving it to the data variable. And what this means is that you've lost what the user really typed in. So you can do it for convenience. You just have to keep in mind that I'm going to lose. I won't know whether or not my user had their caps lock key on or not. So that's the only drawback to doing it here. But I just put it in here as part of the discussion. So anyway, so once I assign the string to data, which is what the user typed in on the keyboard, I just run through my if statement. If the first character they type in as a Y, the print type Y. If they type in N, type N. Otherwise, print valid key. So else if is spelled E-L-I-F in Python instead of else and then if. Okay, so it's just another word to get used to that. Some people also ask whether Python has a question mark colon operator. Okay, so that looks like this. So C question mark true expression. So conditional question mark true expression colon false expression. And Python does have that, except that it's not spelled like that. It's spelled true if conditional else false. So here's an example where I want to assign the smaller of x or y to the smaller variable. So it will be x if x is less than y, otherwise y. So that's Python's version of question mark colon. All right, so that's just the if statement, pretty basic, right? You just, of course, if you're new to Python, you just have to get used to the fact that you have to inject these blocks for the if and the else if and the else. Okay, that's the only real thing you have to worry about. And then loops, most of the time, so Python has two loops, the while loop and the for loop. And I would say that most of the time you're going to be using for loop. It's going to be very, very rare that you use a while loop. The reason is because the for loop is much more powerful and it's much more flexible. And you know, unless you're doing raw counting, you probably won't be using the while loop. In fact, the only time I ever use a while loop is when I'm writing a server. And so my while loop will just be while true colon, because it, you know, servers need to run forever, right? So anyway, so just taking a look at the syntax here, for loop is more like a shell script for each statement. So that's where you have the iterator over a sequence. So it's more of an iteration type of loop instead of a conditional, you know, like for I equals 0, I is less than 10, I plus plus type of thing. That's a more that's a counting loop. Whereas this is a iteration loop. So like I have a list here for every item in my list, print each item. Okay, pretty basic. You want to make Python count, you can use range. So we've already seen that before. So I can do for I in range of 3, which is the same as range of 0, 3. Okay, and that really counts from 0 up to but not including 3. So that's 0, 1, and 2. So print I, 0, 1, and 2. Right? You can do the same thing using a while loop, but again, if the for loop can do it, there's really no need to use a while loop. Right? So very, very infrequent for you to use a while loop. All right, files, pretty basic. There's an open function. You just pass in the file name and what access mode. So I'm going to open a file for read, write, pen. Okay, and once you have an open file, you get a file object back, which is assigned to variable f. And then I can, I can do all kinds of stuff. I can do read from the file, I can read lines from the file, I can write to the file, then I can close the file. All right. And so down here is an example piece of code where I want to take the contents of a text file and just display it to the screen. Very basic. Okay. So I'm going to open the file for read, and then I'm going to iterate for every line in my file. I'm just going to print each line and then close the file. All right. Very basic. Right. Anybody see something weird with my print statement? Something that's kind of weird. There's a comma, all right? Ever seen a comma? Okay. So the reason for this is, remember how I talked about earlier that I had an example of a list comprehension where I stripped off the leading and trailing white space. Okay, so at the end of every line, there's going to be a new line. The problem is print adds a new line too. So if I actually do this without the comma, it'll actually display everything double spaced. Okay, so a comma at the end of the print statement tells the print statement to, hey, don't do your new line. Just display the one from the file so everything looks straight. Okay, so that's the one string. And Python 3, because print is going to be a function instead of a statement, you won't have this comma. It'll just be something else, like n character equals something else. computer, and it'll work. As long as your file exists, okay? If it doesn't, you're going to get an error, all right? Okay, very straightforward. All right, functions. To make a function, you use the def keyword. So you just do def, followed by the name of the function, and then any parameters, colon, and then your indented block of code that makes up the function. Okay? Pretty straightforward. And then when you call it, you just call a function, pass it whatever parameters, and it's going to execute as you should expect it to. Okay? Pretty basic. Okay? And then, like I was saying before, Python has a lot of features that are borrowed, or actually stolen, from functional programming languages, okay, that includes the list comprehensions that we looked at. But one thing that I do have to warn you about with list comprehensions is, although it looks really nice and fancy and neat and stuff, I can build this nice list, this is a very one line of code. The problem with it is, what if the thing that it generates is got like 10 million objects in it? You really don't want to create a list with 10 million objects, because that's just going to eat up all your memory, right? So there's a more memory-friendly version of the list comprehension. It's called a generator expression. And what that will do is that won't make this entire list in memory, but it'll make an object that you can iterate over every single item. Okay? So it's much better for memory, so I highly encourage using generator expressions instead of list comprehensions, unless you really have to have it in the list. Okay? If you do have to have it, that's fine, you can make it, but just be aware that it's taking up memory if you make a big list. All right? Python also supports currying or partial function application. How many people know what currying is here? Okay. No, it's not eating delicious spicy food. Okay. All right. It's being able to take a parameter that you use all the time and kind of caching it in a way. All right. So if you're always calling function foo with 100 and then some other object, and you're just calling foo 100 comma a, foo 100 comma b, foo 100 comma c. All right, you don't want to be typing foo parentheses 100 comma every single time. All right, so curry is a way to take that 100 and sort of build a new function object that you can just do foo 100 parentheses your object. Foo 100 parentheses your object. You don't have to type in 100, but of course I named my new function foo 100, which means I'm typing 100 anyway. But you get the idea. It's to be able to cache objects that you can call functions to a lot. Okay, so that's currying. Partial function applications is the same thing, except I can curry more than one object. Okay? So I can cache like 10 different parameters. I always pass the functions, all right? And also the statically nested, because Python is statically nested scoping, that means you can have inner functions, and that's basically a function defined inside a function, all right? So if you have a lot of repeated code inside your existing function, but it's not going to be used anywhere else, you can actually create a new function inside that function that's only used there, okay? And then you can also do closures as well. I won't get into that, but a closure is if you have a function and it goes away, you should still have access to all the variables in that scope. So that's what a closure is. You can read more about that online. And then Python also has anonymous functions like lambda. It also has things like math and reduce. Okay. So that's functions. Now, remember how I mentioned earlier that Python is very modular? So that means you should only import the modules that you need to get things done. So if you're doing networking, you'll import the networking module. If you want to do databases, you'll import the database module. And then everything else that you're not using, just don't do it. All right, keep your code nice and clean. So how do you bring in code that's used elsewhere? So here are some examples of how to do that. So a long time ago, before Python had string methods, in order to turn a number that is in a string format into a real number, we have to import the string module and call this function called a to I. All right, so you would import string and do string.a to I of my number that says string, and then it'll turn 1, 2, 3 to a real integer, and then it'll assign it to number. Okay. The other way of doing it is using from import. So I can say from string import a to I, and now I can do the same thing, but I don't have to type string.a to I just to call it. Okay. So obviously there's pluses and minuses, obviously this is less typing. The second way of doing it is less typing. Okay, so if you're lazy, okay, that's good. But the problem is, this brings your names into the local namespace. What that means is now that you're using a to I, you can no longer call a variable a to I in your code. Otherwise, you're not going to be able to use it, right? So you're going to share the same variable space. So that's the one thing you have to be careful about if you're using from makes it hard for people to read your code because now when they see something like this, they got to think, well, does this user import from somewhere else, or do they have a function in here called API? Then they have to look around your code to see if they can find it. Okay, so it's a little bit harder to read. So I always encourage beginners to do this way. Okay, even though it's slightly a little bit longer to type. But you know what? If I'm looking at the extra typing I have to do here, it looks like this is more typing up here, just for less savings down there. So it's really not worth it. Okay, so I strongly encourage you guys to do it the first way. But I wanted to show you what alternatives there are. Okay, everyone understand that? Two different ways of doing it. Okay. Yes, question.
Will it override if I do another module import?
Will it override if I do another module import? Okay. Okay. So that leads to another question. So I will answer your question by answering another question that nobody asked yet. Okay. So some people are asking, because I teach a lot, right? I've been teaching Python for like 11 years. So people go, okay, if I have module A that imports module C, and then I have module B that imports module C, what if module A imports module B? Does that mean I import C twice, right? Because A does it, but B does it, but A also imports C. Is everyone confused now? Okay? Right? You guys get what I'm saying, right? You just kind of get, like, it just goes in one ear, not the other. Okay, it doesn't really matter. It's kind of like pretend. So the main question is, what the words import C appears many places that will get executed. Is there a problem? Okay. So the answer is not a problem. So Python is smart enough to know whether or not when you import something, whether or not it's already been imported. Okay. If it's already been imported before, it won't be an issue. Okay. So you can import C as many times as you want, but it will actually check to see if that module has been loaded yet. Only if it has not been loaded, then it will load it and say, okay, check. Done. But if it's already there, then it's just going to skip it and not do anything. So your question is asking, so if I import it here, will I accidentally wipe out something that I may have? And the answer is possible, right? So if you, like somewhere above the oops, so if I have something like A to I equals 10 somewhere up here, and then I have this from import, then I've effectively gotten rid of mine. So if you do this from string import A to I, and you've already been using A to I, then you're basically wiping out the old one. However, if you do this import again later on, it won't have an effect because it's already loaded to the string module. So if I have this from import somewhere else, it won't have an effect.
Say for example, I have instead of string, I have another module that has same API function, and I do an import right after this.
Yes.
So same API.
Yeah. Right. Okay. So your question is more specific. If I have from string import A to I, and then I import something else that has A to I, like from food import A to I, yes, you will override this and you won't have access to it anymore. Okay. The other thing that people ask, which you guys have not asked yet, is they said, oh, wait a minute, won't this one like save a lot of memory? Because here I'm importing the whole string module, and down here I'm only importing one thing from string, right? Come on, who wants to ask that question? I know somebody does. Okay. The answer is no, you don't get any kind of savings because in order to do this, it has to import the whole string module and then go and look for A to I and then give you access to it. You just don't have access to anything else in the string module, even though the whole thing is loaded into memory. So another reason why you shouldn't be doing it this way, you should be doing it that way. Okay? Because if you do it this way, I can do string A to I, string A to F, blah, 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 blah. Okay? But of course, today, in today's Python, you won't be doing this at all. You'll just be calling int unquote A to int on one quote 1, 2, 3 to get a number out of it. You won't have to do any of this extra stuff anymore. Okay? All right, good questions. And then the last thing I wanted to mention is packages. So this allows you to organize your modules using the file system. What does that mean? So let's say you have a startup company, you write your thing in Python, you don't really want to ship your customers 1,000 .py files. Okay? It just doesn't look good in that directory, in that folder. Okay? So what you can do is you can use the file system, create different folders, like this folder is for all the communication stuff, this folder is for the data logic, this folder has modules for this, blah, blah, blah. So you can put all your PY files in all these multiple directories, and then you can just do import using the packaging syntax, which is the same as import. So I can be like import project dot, data communication dot function, and it'll work right, even though it's divided up into a file system stuff. They're not like, those are called packages and sub-packages. Okay, so that's what the package is. All right, so a lot of people say, well, you told me that Python is batteries included. It's very robust. What does that mean? What software does Python come with when I download it? What can I build with it, as soon as I have it on my system? Here's just an example of what is in the standard library. So what is the standard library? sys and OS, those are for like system stuff, operating system stuff, file system stuff. Then you got stuff for regular expressions, CSV files, date and time calendar stuff, network programming with sockets, SQLite for databases. For a database, you can also get an adapter for MySQL and Postgres, and Oracle and SQL Server. Some process for outside to fork off, start different processes and programs running. You can do email parsing. You can build email, send email. You can do GUI programming. You can have threading. And also multiprocessing, like multi-core, multi-process stuff. You can flatten your Python objects or serialize them. That's basically, I have a Python object. I want to store it to disk. How do I do that? And so Pickle will serialize that object to a flat binary string. You write that to disk. When you bring it back, you can tell Python to pop that back up into a full object. Okay? So that's serializing and deserializing. You can do math stuff. You can do archiving and compression like zip files, tar files, gzip files. You can write all kinds of internet code like email, FTP, HTTP, SMTP, any internet-related stuff. And then you can do XML parsing. You can have an XML tree. So, and then there's other libraries. I should probably put JSON on here because that's another popular type of data format. It supports attributes? What do you mean by attributes? Oh, you mean add sign? Kind of like, oh, yeah, so that's called a decorator. So Python has that too. I just didn't mention it here. Yeah. So the question was, does it have attributes? So in Python, those are called decorators. So you have the @ symbol, so you can basically do logging and those extra curricular things, timing, things like that. So you can do all those cross-cutting things. It's really part of a whole group of things called aspect-oriented programming. The reason why it's called cross-cutting is because like logging and timing is not actually related to your app, but it's like information that is useful to you for your app. Like you want to find out how long it takes to execute these functions, how often do people call these functions, and I want to log every single time somebody calls this function and see what the parameters are. So all these things, yes, you can decorate your functions or your classes in Python to be able to register those things, which are not really related to your solution, but you want to save some additional metadata. Okay, so Python, I said, is object-oriented as well. So if you really, if you're writing a larger app and you feel that you need to have an object that models the real-life situation that you're trying to solve, you can do that. And the way you create the class in Python is you use the class keyword and the name for the class. The recommended style is just like other languages where your class name should be capitalized so that it helps distinguish the class between the class and a variable. And then you have all the base classes that you're inheriting from. One thing that is different in Python is that because Python does memory management for you, there is no new keyword. Python actually makes the object for you. And because of that, there's no constructor. There's no such thing as a constructor or destructor in Python. Because Python makes the object for you, all right? But what it does have, it has something very similar to a constructor called an initializer. So Python makes the object for you, and then it calls your initializer so you can set up your instance before Python gives it back to you. All right, so that it's kind of like a courtesy thing. So because it's an initializer, it's called init. And anything that is very special in Python will have double underscores in front of it and behind it. So 2 underscores, init, underscore, underscore. Okay, double underscore, init. So that is the Python initializer. And if you do have one in your class, you have to call it by that name. Okay? There is no destructor. Python does kind of have one called a terminator, but it's really not used that much, again, because Python manages memory for you. There is no need to have a destructor at all. Okay? There's also some security issues and concerns. If you really want to find out why there's no such thing as a destructor or terminator, you can talk to me privately and I'll tell you more specifically why. But regular methods don't have underscores, so this one's just called times, which is going to be multiply. The other thing that you'll see is this word self. So self is the same thing as this from other object-oriented languages. And Python Actually, it requires you to type in self because it wants you to be explicit. Okay, you don't want to like have to guess where things come from. So Python forces you to do that. So that's the bad news. A lot of people complain about it. But the good news is when you're calling your methods, you don't have to pass it in. And so in this particular case, here's an example of how you create an instance of this class object. So there is no new keyword like I said. So the way you create an instance of a class is you call the class as if it was a function. So you see that? My class and then paren. Okay. What do I pass in? Well, remember how I said Python makes the object for you, and then it calls the initializer on your behalf before you get it back. So whatever you pass in is the object that goes into the initializer. Again, even though Python forces you to type itself as part of your method declaration, it passes in the instance for you, so you don't have to pass it in. So I only have to pass in data in this example. So down here, when I make my new my class instance, I only have to pass in the variable that goes into the data field, right? If I don't pass anything in, if I just have paren, it will take this default value. So you can actually specify default values in Python. If there's an equal sign followed by a value, it will take on that. It'll take on that value if I don't pass in anything. Okay, so this is not just for classes; it's just regular functions as well. All right. So so this thing will just call under init. Python makes the object for you. It passes itself. You pass it 21. It assigns self.info equals 21. So now that I get it back, I can just dump off the contents of it. Okay. Notice I don't have to write a getter or a setter or anything like that. Don't code Java using Python syntax. Okay. There is no concept of getters and setters. You just don't do that. Right. You just access the item directly. And again, if there's a security issue, you build a security policy that will prevent users from doing this. Okay, and you can't do that. All right, and then I can call a method by doing int.times3. So I'm going to multiply it by 3. So again, the 3 gets passed into x. Python passes itself for me, which is going to be that instance. And it's going to do something times something gives something. So self.info, which is 21, times x, which is 3, is, and then I perform the actual calculation right here. Self.info times x. So it's 21 times 3 is 63. All right? Is that pretty good? All right, you guys understand that? Fairly straightforward. All right? 6 more minutes. Just hold on tight. It's almost over, and you can get the glorious food back there. Okay? All right, exceptions. Handling runtime errors. What do? So you have this try command and then a block of code that you want to monitor in case there's an error at runtime. And in this particular example here, I'm going to open a file that doesn't exist. Okay? So data.text doesn't exist in my system, and I know that Python is going to throw this error called IO error. Okay? And there's an as here, the word as, E. Okay? And this is only in 2.6 and newer. So if you're using 2.5 and older, you can't have the word as here. That's why it's not blocked out. You actually have a comma. So it would be except IO error, comma, E. But they've changed that starting in 2.6. Actually, 2.6 will accept both formats, and 2.7 as well. But in Python 3, you have to have the as here. All right? So that E variable is going to contain the reason why the error happened. So you can save that. You don't have to. It's optional. If you don't save it, that's fine. But maybe I want to log why it happened, or maybe I want to tell the user why. Okay, so in this particular case, I can tell the user there's a file open error. It's going to say something like file does not exist. Okay, and then I just pretend I return false or whatever kind of processing that you do if something bad happens. All right, so the block of code in this try can be obviously more than 1 line. It could be like 200 lines. All right, and then if it catches this type of error, it's going to run this code. You can also add other handlers, like I can accept some other type of error, accept another error, accept another error. So I'm going to have a whole chain of these exception handlers. All right, and if you want to throw an exception, you would use the raise command. So you would raise some error, give the reason for the error, etc. So it's the other way than handling. There's also a try finally, just like in Java. That's not used to catch errors, but it's used to run code that has to, whether there's an error or not. Like, you got to close the file. You got to release a database connection back to the tool. You've got to release some kind of lock or something. All right. So try finally is used to run code that must run regardless of whether an error happened or not. Okay. All right. So another question that people ask is, are there any programming tools that come with Python? The answer is yes. There's a debugger called PDB. You can start it up and test your code that way, or you can have it so that you can immediately, you run through your code and then you pop out into the debugger if you want, or you can make it pop out into the debugger only if your program crashes. Okay, so there's lots of different ways of using the debugger. It's called PDB, read about it. Again, it comes shipped with Python, so you have to worry with it. There's also profilers. So, does everybody know what a profiler is? Basically, it's a thing that helps you measure how well your application is performing. It tells you like how many times did you make this function call, how long did it take to run this function every time, and all that kind of stuff. So it gives you measurements as to, you can find your bottleneck, places where your code is not optimal, and so you can go and fix it and make the program run faster. The one you probably use is called C profile. That's the one on the bottom. I listed these in chronological order. Profile is the oldest one. Hotshot came around in like Python 2.2. It was like the next generation. And then unfortunately they discovered there was a bug in it. And by the time they fixed the bug, somebody was already putting C profile into Python. So it's kind of sad. Anyway, so C profile will be the one you're probably going to be using. There's also a tracer or a tracker, and what that does, if you want to like look at some code, execute some code, you can find out exactly how things go, like what function call it made, what's the stack frame look like, which ones get called before which, and all that stuff. So that's what tracer does. It traces your execution. It's also a timer, so that if you want to measure, how fast something works, you can take a chunk of Python code, pass it and time it, it'll run it like 1,000,000 times and tell you the average running time. So that if you, came up with like 3 different ways of solving the same problem, you want to find out which one is faster, you just pass all 3 of those into time and you can see the performance of each one. It's pretty nice. It's also a logging module, which is really good because, a lot of times when we're writing software, we have to log. Like, is this an error? Is this a warning? Is this info? Is this a bug? Or what? So all those things are already built into the logging system, so you don't have to build your own. Again, there's batteries included. Okay. Even has a lot of logging classes you can use, like I want my logs to roll over every night at midnight, or I want to roll over my logs when it hits like 200 megs inside or something like that. So there's a lot of different classes that help you with these things. Okay, and as far as testing goes, there's a unit test. Unit test module is just like JUnit for Java. So it's just the standard unit testing framework. There's also a doc test, which I won't have time to get into today, but it's very useful. If you want to include some example code usage in your documentation for your, kind of like Java doc format, except doc test will actually look to see if you have running code in your Java doc or your Python doc, your documentation, and if it does, it tries to run tests on it. So doc test is kind of useful, but I won't have time to go into today. And then there's 2 other external testing modules that you can look at. They're called nose and Py.test. They're both very popular. And they're both a little bit easier to use than unit tests. So a lot of people use those tools instead of unit tests because maybe they're not comfortable with object-oriented programming because unit tests requires you to be able to create test classes. And maybe you just want to have it really be easier to understand, easier to write tests. So that's why people use nose and Py.test. All right. So before we end, there's a couple more slides left. So. Python 2 versus 3. So this is a big topic. I actually gave, at the PyCon conference down at the Singapore Management University that I gave on Thursday, I talked about Python 2 versus Python 3 and why there's a big deal that Python 3 is backwards compatible with Python 2. I tried to tell people that, it's not a big deal. The language is not really going to change radically. And the main reasons for doing so is because there are a lot of these design flaws that they really wanted to get rid of the language. And it's a way to improve Python, to make it better, to evolve, to become the next generation. So that's why they did it, not to frustrate users. All right, it's very important to preserve backwards compatibility. The entire development team feels that is a top priority for them. So the fact that they are breaking backwards compatibility means there's a more compelling reason why they did that. All right, so some of the changes I kind of already mentioned to you, like print is changing to a function. We have true division, a lot of performance enhancements. A lot of people, because Python is now becoming more of an international language, there's a problem with having Unicode characters and strings and not ASCII characters, so that's been a problem in Python 2 for a while, so that's going to be changed. So that in Python 3, all strings are Unicode by default. So that's a very big change, and then some additional smaller changes. About a year ago, I wrote an article on Python 3. So you can probably look that up online, but it's probably better to go and find a video of my talk on Python 3 means for them to upload the one that I did the other day, but I did this a very similar talk at the PyCon conference in America back in February. So that is online, so you can check that out if you're interested. So anyway, so that's all I wanted to say about Python 2 versus 3. Just be prepared that backwards and compatible. If you guys are new to Python, your question may be asking me, so which one should I learn? Should I learn Python 2 or Python 3? And the answer is, if you're completely new to Python, your company doesn't use it, and you just want to play with it and experiment, then you should use Python 3 because you have no legacy. But if you want code that has to run in production today, probably want to use Python 2 because there's more code available in Python 2 right now. It's just we're in the middle of the transition process. So Python 2 is not dead. In fact, Python 2.7 is the next version of Python 2, and that's coming out at the end of this month. So both 2 and 3 are being worked on at the same time. It's not like, oh, all of a sudden, Python 2 is dead, don't do it anymore. Okay, that's not the case. They're both being worked on actively, and every succeeding release of Python 2 is going to have more Python 3 features backported to it. So by the time we get done with Python 2, you'll be able to code Python 3 very easily. Okay, so it's not gone. It'll be right. In fact, Python 2 will be around for years, and I'm gonna go as far as to say I think it'll be around for 10 years. Right? I think it'll be around for a long time because it's gonna take a lot of effort to port. All right. So now that you guys know something about Python, what can you do with it? All right. You can do anything that you can think of, even things that you can't think of. You can do with it. Okay, I know that sounds funny, but I can just say all these things up here. I can say system administration, XML processing, GUIs, multi-threaded, scientific stuff, Java, graphics, web things. I can say all that stuff, but I can also tell you things that are completely unexpected, like mapping the sparse galaxies very far away in space, or controlling underwater robots, or interpolating damaged musical scores from the 1800s. Okay. All of those things have been done with Python before. Even analyzing patients that have spinal fractures, right? So Python has been used for anything and everything that you can think of and things that you haven't thought of. So before you start coding, of course, try and hunt around to make sure you're not going to do the wheel again. All right? So just make sure that somebody hasn't already done something. If you want to find out more about Python, a couple of good books. Of course, I recommend mine. If it was a bad book, actually, I wouldn't recommend it. So. But it seems to get pretty good reviews on Amazon and stuff, so I'm pretty happy about that. There's a new printing of it. You'll see it if you go to the bookstore. It has a red star on it. And if it has a red star, I think that's the newest one. Because that's a new Python 2.6 and Python 3 stuff that I added very recently. Let's see, they're all pretty good books. They all have, if you want to ask me specifically about each one, I'll tell you the good things and the bad things about them. They're all meant for a different type of reader audience. Okay, and then there's a bunch of reference books which are very general. So Essential Reference in a Nutshell are two very good reference books that you can just pull off the shelf and look things up. Okay, so they're not really for learning; they're for looking things up. Like, does Python have a package that does X? Does Python have a package that does that? Y, etc. Okay, and there's a bunch of online tutorials, a quick reference guide, and all that kind of stuff. All right, so lots of resources. So I'm here visiting Singapore for a few more days, even though the PyCon conference is over yesterday. I'll be around, like I said. I'll be leaving on Wednesday. But if you happen to be in the UK next month, I will be speaking at the EuroPython conference as well. All right, so that's it as far as Python goes. So I think it's time for you guys to take a break, get some food and drink, recharge, and feed your stomachs, because I'm hungry.